So let's start, let's resume, and I want to go through the quiz quickly so you all get a overview of what was in the quiz. So the first question here is about extensions. How many of you read the chapter on extensions? Some of you did. Extensions, what is an extension? Can anybody define it? Yeah, in Java you say extends to extend the class. Basically, when you're subclassing something. In Swift, extensions are like that, but in a more limited sense. They don't allow you to do everything. That's why this question. Extensions do not give you the ability to provide which of the following. So extensions allow you to create computed properties. So let's look at that. Swift extension. What does an extension do? It allows you to create computed properties. And what is a computed property? For example, here there is an example. There is an extension of the class double. Now double is the native Swift class to store decimal numbers. It is being extended here. And what does it do? This is the key line. So if the number is assumed to be in meters, it returns the number itself. But anything else, if you want it in centimeters, it will multiply by 100. If you want it in feet, it will divide by 3.2808. So basically, that's what it does. And this is an example. Let 1 inch equal to 25.4 dot mm. So dot mm returns this computed property, right? That's what it is doing. So extensions allow you to create these computed properties. So the number itself holds just, in meters, and then everything else is computed. So this was a part of the question. Similarly, new instance types or methods, you can create new instance types, meaning additional methods to do what you want to do. And this, in the example of this, you will see in the next couple of questions an example, right? New initializers, but what it doesn't allow you is new implementations for existing instance or type methods. You cannot override. In an extension, you cannot override what is already available. You can only do new things. What does this code snippet do? Extension array, and there is a function called shuffled. So intuitively also you could have solved this. It is returning an array. It's not returning the self object. So basically adds a computed property. It's a function, it's not a property. So the A is out, C is out, it's not shuffling it in place, it's returning a new array. It adds a method that returns a shuffled copy of the array. Third question, what does this code snippet do? Extension string class is being extended, and there is a variable called reversed, and it returns a new string. It reverses the characters of the string and creates a new string to return it. So it is a computed property because it's a property, it's not a method. Adds a computed property that returns a reversed copy of the string. It is a copy because it created a new string. Okay. When is it useful to define a custom structure? We defined one before the break. We'll define one more after the break now. And the answer to this is when you want to represent a new type of data with a collection of property and functions. So this question actually we answered before the break. You can use a table view without a table view controller. This is not from your homework, this is from what we did in class. And I explained it when we were adding the table view controller that you could actually use a table view, but you have to do all the auxiliary functions like scrolling and all those things that table view controller gives you. So the answer is true. And this also we talked about which data source methods are required for table views. So in terms of required, these two are essential, B and C. Without this, your code won't even compile. The others are optional. They have default implementation. Okay. So that was your quiz. Are the quizzes getting easier? Harder? Okay. How many of you are reading? Are you reading your homework assignments? So this, right, because this was covered in class. Yes. So it is a mix. This was a slight twist. So far, your quizzes were straight from your homework. This one had a couple of questions about which we talked in class. So you can expect some variation. So it's also not that you find it really easy. Okay, good, good. But many of you did well, so that's okay. All right. Let's move on to what we were doing. We had implemented the save game function and we were calling it as and when a game was being finished. So the game is being saved. Now we want to start displaying the saved games. So to do that, go to your TableView controller class. So we have these functions here, return number of sections. You might remember what these sections are. It's like the table is divided into many sections. In our case, there is only one section, so it returns one, and that's fine. But what about the next function? Number of rows in section. What should it return? It's right now returning 5 or some other number if you have chosen some other number. What should it actually return? How about this? Number of games played. That's how many rows are there. So if you have played 10 games, it should return 10. So we need to retrieve the number of games played. So over here, instead of returning 5, you just say return. So we'll invoke the standard object and then return the integer for which key? Constants dot num games. So this is what it will do. So now if you run your app, you should see instead of whatever rows, number of rows you were seeing before, you should see the number of games, number of rows to be exactly the same as the number of games you have played since we implemented the save game. It will still just say oh 1 and today or whatever it is. We have not yet connected that part. So it still has the dummy data in the cell, but now the number of cells it is showing, number of rows in this table is going to be the same as number of games you have played, and you can test it. Play another game, restart your app, you will see another row. So you have to restart to see it because right now even that part is not done. Okay, so now the game is in this case one game was played. I can play another game. Okay, now if I go back, it still shows only one, but actually it has saved two. The table is not getting updated. Now when I say click here, it should show 2 games. So the number of games is now correctly being displayed. We want the data for each game also. And for each game, we are saving these 3 things. So we want to retrieve it and use it. How are we going to do it? This is how we are going to do it. We'll scroll to the bottom of this and we'll define another struct. we want to define a data type which stores these three things, our own data type, through a struct, and we'll call it game data. And these are the things we need: who won the game, type is string, date time. What is the type of date time? Date. What we saved, that's the type we want to use here. And order. What is the type for this? What's the data type for order of moves? What did we save? Just integer or exactly an array. So an array like this of integers, so that is what it is. So this gives us a way to declare a variable that contains everything about each game that that we have saved. So now we have this struct defined. Let's declare a function that will load all the data that is saved. Just like we have save game function, we'll create a function called load data, and we'll load all the data. So scroll up, and where it has this comment table view data source, this is where we'll create a function called load data and use the indentation that Swift does for you. Okay. So to load the data, first we need what? What do we need to know? We need to know how much data to load. So we need to know the number of games played, right? That's the first thing we need. So we'll do that here. Let number of games played, and we'll retrieve this. You can actually just copy and paste this from here. You see where you are returning the number of games, you can just copy and paste it here. So that is our number of games played. Now let's say this returned the number, it returned 4. What do we need to do now? So this will return a number, the actual number of games you have played so far. Let's assume 4. What do you need to do next? You need to load the data for each of those 4 games so you can display it in the table. And how will you do that? Yes, we'll populate that, but you need to use a certain feature, certain construct to be able to do that. You need to iterate, loop. You need to loop. You need to loop so many times, number of games played times, right? So we'll say for, and Swift, those you will see it in the book. I'm not going to go into the details, but the syntax is slightly different from what you have seen in other languages, but the purpose is the same. So when I say for I in, and let's say I go from 0 to less than number of, this defines a range, 0 dot dot less than. So it goes from 0 to the number 1 less than this, basically. It won't go to this. So it will iterate that many times. Okay, so I is the game number, or is it? I is the iteration number. Our game number is does not. What does our game number begin at? Did we start at 0 or 1? This 0. When we were saving, did we start at 0 or 1? When we were saving, 1. When we were saving, we started with 1. So when we are retrieving, we need to start with 1. So let's say game number equal to I plus 1. And now let's get who won this game will retrieve its value. What is the data type of who won? String. So when we said user defaults dot standard and we want to retrieve it, we'll use the function which is appropriate, which is this string. Okay. What's the key? When we saved it, what key did we use? Constants dot who won. Was that it? Check your code where you're saving it. What is there in the key? In the save game function, what is the key? Who won? Is that it or there is more? Plus the current game number. Otherwise it won't retrieve. So plus the current game number converted to this to a string. The same way we'll get the date time for this game. Now date time, what was its type when we saved it? Date. So to retrieve it, we are looking for a type called date, but there is no date type. So we'll retrieve it as any, exactly, as this, as any, meaning this object. So we'll call this object class, object method. Okay, and so once again our key is constants.datetime plus the game number. Okay, so this object class returns an object of type any, but we want a date, we don't want any. How do we do that now? How do we get a date from any? How do you change the type? What's the word? What's the word we are looking for? Casting, type casting. We need to cast it to its type, right? So this is the any object, we'll cast it to a date object. So that's to do that. In Java, how would you do that? If you had an object of type, some type, and you wanted to cast it to another, how do you do that? Yes, in brackets just before it, right? That's casting in Java. In Swift, there is, the same thing is done by using this keyword as and the new type. So as date, that will cast it to a date. Any is not convertible to date. Why are we getting that error? So the reason for this is simple. When you have a class, right? Let's say this is the parent class, and you define subclasses. Okay, let's say we're talking about shapes, and you define a class called shape, which may have area, whatever defined, perimeter, and then you define a class called square, circle, etc. So a square is a shape, but a shape is not necessarily a square. It may be a square, but it could also be a circle. It could also be a triangle. So if you try to cast from square to shape, you will be successful because all squares are also shapes. But if you say cast, I have an object of class shape, and you say change that to a square, it may or may not work. That's what this is. That's what is happening here because all objects are of type any. They're all any objects. But all any objects are not dates. It could be a string, it could be an integer, it could be whatever it wants to be. So this is why we are getting this error that it is not convertible. But Swift allows us to fix it by forcing downcast. So if you click fix, it will replace as with as exclamation. What that means is that you, the developer, is giving the guarantee that you know that this is a date. If it's not a date, the program will crash. But since we saved it, we know we saved a date, so we'll retrieve a date. So we can do it. We can force downcast. Okay. So now let's now get the order of moves of this game. Now order of moves is an array, and this provides us a method to retrieve an array. So we'll just say use this method, retrieve the array for the key that we know what key we used. It was the order of moves plus the game number as in the other two cases. So we got these three things. And we created that struct at the bottom called game data, which allows us to store these three properties. So now we can create an instance of that struct. We can create an object. And let's do that. Let's say this game data equal to. So as you start typing here, game data, that's our type. You select it, and then you, as soon as you say opening bracket, it will give you the initializer. You should see that it takes three things: who1, which is a string; date time, which is a date; and order of moves, which is an array of integers. So you select that, and now you can specify these three things. Okay, so who1 is a string. So what is the variable name we have chosen? We have chosen this, who won this game. So just type here who won this game. Date time this game. So that's the variable name. An order of moves is an array of integers, but what is the type here? This is an array of any objects. We need to cast it just like we did the casting with the date. So that's what you will do. You will add a cast to an array of integers. Cast an array of any objects to an array of integers. And then we can use it here. Order of moves this game. Okay, so do you guys have an error after you add this much? So the error message says value of type string question mark. What is this string question mark? You remember we talked about this when there is a question mark. It means the value is optional. It can be nil. It may not exist. This who won this game, there is no guarantee that this key is stored with a value. So it could potentially, by definition, it could return nil. If the key is not found, it will return nil. But we know that the key is there, we have saved it. So we force unwrap it. So if you see here, you will see an option, the last one, force unwrap using exclamation. Because we know that it is it is there in the database, we have saved it, so we just say fix, and you will see that it adds an exclamation after that variable. So now it has retrieved the data, the game data, and initialized an object of this struct that we created. Okay, so let's say you have played the game 10 times, and this loop will run 10 times, and you will get 10 objects of this game data. But in the loop right now, the object is created and then it's lost. It's created and it's lost. We are not saving it. So we need to keep track of all of those 10 objects so that we can use that information to create the table, who won the game, when it was played, etc. So how do we keep track of it? So at this point, this game data, this variable, we need to store it so that it becomes available outside the for loop in the class. And the way we will do it, we'll create an array of that class, of that struct. So this is how you will do it. You'll say variable this creates an array of game data. Okay, so once you add this line, your variable has got declared now. Now each data point we read for each game number 1, we add it to this array. Game number 2, we add it to this array. So this becomes available to us. When the table is being built and the table view controller says, get me the first row, you will say, okay, what is the game data for the first row? Who won the game? What was the time? Assign all that and return that. So this is what we'll do, game data array, and we will append it here. This game data, we'll just say game data array dot append new element. What do we say here? What are we appending? It's an array of game data, so it has to be an object of type game data. So this game data, exactly. Okay, perfect. So now our data is being saved and being loaded. Well, we have a function to load it. We haven't called it yet. We need to call it from somewhere. And what happens is, to know where to call it, we need to understand how this table view controller works. Okay, let me just display that for some more time so that so you need this line inside your for loop, game data array dot append. So the way the table view controller works is, when the table is displayed, it is loaded into the memory first before it is displayed. And when it is finished loading, this function is called. This is called automatically by the UI manager, whatever is managing the views. This is where we can load the data. Because after this, after it is loaded, the view controller, table view controller is loaded, it will start making the table, it will start requesting the rows. So this is where you add a function called to load data. Inside the view did load function. Okay, now we have got the load data function, it is being called. Let's scroll to the point where we have this function table view self or row at. This is where we are saying O1 and when it was today. Okay, now We are getting closer and closer. So this, if you examine this function declaration, it has the table view it receives as an argument. Then there is a label called self or row at, but there is a variable name after that called index path, which is of type index path with capital I. What is this index path? It's made up of two properties, section and row. And we have only one section, so we don't care about the section property. We are interested in the row property. So for the first row, for the second row, that number will keep changing, and it is zero based, so it will start with a 0. So let's get that. Let index path dot, if you say dot, you will see there is a property called row, and there is one called section. So just take row. So that is our row number. In the first row, the row number is 0, but our game numbering starts with 1. So we'll add 1 to this. Let, oh well, maybe not. Hang on a second. Our game numbering starts with 1, but our game data array starts with 0. So we can just go with that. There is 1-to-1 correspondence. We don't need to add 1. So we'll just say this row data. What is the data for this row? We will retrieve it from game data array and just provide it the row number. So this will get us this row data. Perfect. Now we need to set who won the game. Okay, so instead of saying O1, we will say this row data dot who won, right? This, what are we storing in who won? They're storing either X or O. They're not using the word 1, so we need to append that here. Space and 1. Okay, what happens when it's a draw? So, okay, let's add this much and then we'll go back to our save game and see what the value of who won is when the game ends in a draw. If you go to your game model, you will see that who won is declared as an empty string, right? There is nothing, not even a space. It's an empty string. It's completely empty. And it remains empty unless somebody wins the game. It only changes when somebody has won the game, otherwise it remains empty. So that's what we need to look for. We need to look for that here. So before this, let's say if this row data dot who won, if it is an empty string, then we will say that it's a draw. The text of the who won label else, put the statement we wrote earlier inside the else, that somebody won the game. This is what you should have, these 5 lines. Okay, at this point you can run your app and see what if there is any change. So instead of the whatever labels we were using, by default it was saying O1 everywhere, but now it should show the actual result. So now we are one step closer. We are able to display who won. Let's display the date and time. So we want to actually to display the date, we want to format it. See, look here in the documentation for the date class, it gives a hint at the top. Use date values in conjunction with date formatter instances to create localized representation of dates and times. So let's go look at this date formatter and what it does. Okay. So here are some examples of date formatter. So you create an instance of the date formatter class and you say date style, medium, time style, none. So this is all internally defined. And then you create a date object and then you say, okay, my locale meaning the place, the locale on the phone may be different. Somebody in South Korea would want to see different date displayed. In French, it would be different. In every language, it would be different. And you don't have to worry about all that. You just define what locale you're working with. So it creates. If you say English US, the date will look like this. If you say French from France, it will look like this. In Japan, it will look like this. So every place has its own convention of how the date is represented. So what you want to do is just Google Swift date and you will reach this. Okay, Swift date, and you should Google because then you can just cut and paste that, copy and paste. Otherwise, you will be typing everything and it will take more time. So you'll reach the date and then you can go to date formatter. And from date you can jump to date formatter or you can just Google Swift date formatter and you will land right here. So we will select these top few lines, okay, all the way from there up to where it is printing the date. In date, in the first paragraph there is a link to date formatter. Copy this and we'll take it back to the so now we have got date formatter, date style, medium, time style, none. Let's say we want to display a time. So instead of none, we can choose short. Okay, and this here code is specific for this date. We don't care about this date, we'll just delete it. We'll put our own date. So now this is what, and it's looking for that same date, but we have our own date. Where is it? Our own date. This row data. So this row data dot date time. This is our date. This statement is just printing it. We actually don't care much about printing it. What we want is we assign it to this cell date time label where it right now says today. Delete that today and just this entire thing date formatter dot string. You will get that and place it here. So that way your date time label dot text will become that. And make sure you have date style as medium and time style as short. And now if we run, what we expect is that next to that who won, instead of it saying today, it should show us the actual date and time like this. You're getting errors. So you copied that portion from the other, okay? Then you make sure that your date and time style are correct and delete that line let date equal to something. And in here you have to say, instead of date, you have to say this row data dot date time. So at this point, let's try one more thing. I'm going to say short date format as well. So let's see if it fits. So this way it fits. We don't have to do anything. But if you like the other format, just go to the storyboard and stretch your label a bit. So you have two choices to not have your text cut off. You can either change the date style to short, still getting cut off. Then what you do is you go to the storyboard, main storyboard, select that label, okay, and make it wider, stretch it. Yes, date or time, just stretch it to the left a bit. So when it is long enough, it will not cut, truncate, it will not cut. Okay, so where are we now? We've got to a point where our games, past games, are being displayed properly. We know how many games were played, when they were played, what the result was. We were also, in our design, we have an image that we could show here, but rather than doing that, I want to recreate the game. How about that? So when we click this, we want something to happen. We want that game to show up. And we don't have time to do both of those things, so we'll pick what is more interesting. So let's say we click this. How do we know what happens when it is clicked, right? So to do that, go back to your storyboard. And right now we have one segue going from your table to the game board. You click on it and you will see what is triggering it, which is this plus. Okay. So while this is, click on it and then go to open your inspectors and go to its properties. And you give it an identifier called new game. Identifier is missing, call it new game. So you're identifying this segue. It's called new game now. Okay. So now we've given it an identifier. Now what we want to do is open your game hierarchy and make sure you can see this table view. From your table cell, do a right click, drag to this game board. From the table cell, like you're seeing on my screen here, I started from the table cell and brought it to the game board and then release it. And then it will ask you what is the action, you will say show. Okay, it will add another segue. Now you see there are two of these arrows. So select the one that you just added, which is appearing in gray, and you will see that it has no identifier. For that you will add an identifier past game. So we have a new game segue and a past game segue. So now you run your app and see what happens when you click on one of those past games. What happens? Those of you who have done it, what happened when you clicked on the table cell? Did it open the past game or not? No. What did it open? New game, right? Because we haven't coded it yet. Now, so Everybody up to this point? No? What's going on? So let's do this. The only bit we are missing is this navigation. So in your table view controller, scroll to the bottom until you see this section that is commented out. It's called navigation. Okay. So this is where you see prepare for segue. So this is where the execution comes whenever there is a segue. And this is where we can decide what to do, whether to go to the new game or show a past game. So this is at the bottom, it's commented out. Just uncomment it. Remove these things. I'll do it again. Remove the commenting. Remove this and this. Okay. At this point, we have given the two identifiers to the segues. So let's retrieve them. So this variable segue is being passed and it has the property identifier. So now we know which kind of segue it is. Now what we want to do is we want to do something when it's a past game and something else when it's a new game. So new game, it's already working. Whatever it's doing right now is fine for the new game. All we need to code for is the past game. So what we will do is we'll just say if identifier is not equal to, oh no, let's go with equal to. Don't say not equal to. If it is equal to, now here when you type new game, you type exactly as you gave in the identifier. If you use the capital N, you type a capital N here. If you use the small n, you type a small n. So when it's a new game, it will just return. Otherwise, it will try to recreate a past game. Okay, I'm looking at this here, and I think it may be too ambitious to finish it today. We have to connect this, we have to pass the information. So what is happening is your history of games shows whatever number of games. So when you touch on it, this is where you will say, okay, which row was touched? Was it the third row? Was it the fourth row? And then the data for that game, you will pass it to the game board and say, okay, replay this game. So there is quite a bit, and we have about 7 minutes before the official close of the class, and I don't think we can accomplish all of that in 7 minutes without rushing it so much that most of you will not get what is going on. And that's not our point. We don't want to rush it. We are not in a rush. We have brought it to a very good logical point where you are able to see that you are able to play the games on a game board you created. You are able to view all the old games, the data that is appearing in the table. So we are at a very good point. So what I would do at this point is we will stop this here and we will finish it at the beginning of the next class after the midterm. What I will do at this point is I will tell you about the midterm instead of trying to rush this. And this is important stuff. You need to learn how to handle segues when there are multiple segues, what to do. So we'll leave that out. So at this point you can just save it. It's not going to do anything. And we'll go to the other topic where I will talk about the midterm. What is it? What is going to be in the exam? Your exam will require you to develop this design and develop a simple app. Nothing like the complexity we are handling right now because that's too much to do in one exam, one sitting. So what you will have is a simple app and it will test your knowledge of Xcode and interface builder. What does that mean? Doing things like creating an outlet or creating adding a new file, those kind of things you need to know. And you have all done that multiple times. So you should feel confident about doing it. Connecting the view to the controller. So sometimes we have done this like in this same example that we are working with, we added this as a table view controller, right? And then we added a class called TableView controller, which was a subclass of UI TableView controller. And then how did we connect that class with this view? You go into the identity inspector, you select the view controller and you specify it here. So this you need to know. If you are creating a multi-view app, you will be adding more and more. And you'll be adding a class, corresponding controller class. So how do you connect? Using this. Same thing you did with the game. So if you were to go to the game, new game, you added your game view controller here. So that's the other part, implementing app logic. So whatever app, whatever task you get, it will require you to implement something. Something should happen. Like if it's an app, something should happen. You touch, something should happen. So that logic you will need to implement in Swift. So whatever Swift you have been using, that kind of thing. Okay, so this happened, this got touched. So I need to change something. What do I need to change, and what exactly it is? And finally, testing the app in the simulator, which you do several times in every class. So not a big deal at all. Okay, any questions related to the exam?